NASA's recent analysis of samples collected from the asteroid Bennu has unveiled astonishing insights into the origins of life, suggesting that the building blocks of life may be more widespread throughout the universe than previously thought. This revelation not only challenges our understanding of how life emerged on Earth but also raises intriguing possibilities regarding the potential for life elsewhere in the solar system. The samples brought back to Earth by NASA's OSIRIS-REx spacecraft in September 2023 contain a diverse array of organic molecules, including 14 of the 20 amino acids essential for protein formation. Additionally, the samples revealed the presence of nucleobases, key components of DNA and RNA, indicating that the fundamental ingredients for life were present on Bennu, a 4.5 billion-year-old asteroid. This finding bolsters the hypothesis that asteroids may have delivered life's essential components to the early Earth, providing a favorable environment for the emergence of life. Daniel Glavin, a senior scientist at NASA's Goddard Space Flight Center and co-author of the study published in the journal Nature, emphasized the significance of these findings, stating, "Our odds of finding life elsewhere are increasing." The pristine nature of the Bennu samples preserved from contamination by Earth's atmosphere allows scientists to analyze them with greater confidence than meteorite fragments that have undergone atmospheric entry. The research teams conducting the studies found a staggering 16,000 types of organic molecules within the samples, alongside evidence of salty minerals reminiscent of sodium-rich crusts found in Earth's dry lakebeds. These salts are believed to be remnants of an ancient watery environment, hinting at the conditions that may have fostered the development of life. Tim McCoy, curator of meteorites at the Smithsonian National Museum of Natural History and co-author of the studies, described the environment as potentially essential for the steps leading to life, combining the ingredients of life with an environment of sodium-rich salt water or brines is really the pathway to life. The implications of these findings are profound, suggesting that the processes that lead to life's building blocks may have been more common across the early solar system than previously acknowledged. David Deemer, an astrobiologist not involved in the studies, praised the research as groundbreaking. "These are going to be classics," he remarked, highlighting the new insights into the chemistry of the early solar system. Researchers are eager to continue analyzing unstudied material from the Bennu samples, hoping to uncover even more complex compounds that could provide further clues about the origins of life. Despite this excitement, scientists are cautious about expectations, clarifying that while the samples contain the precursors to life, they do not evidence the presence of actual living organisms. The findings from Bennu also prompt a re-evaluation of other celestial bodies in our solar system. The conditions that allowed for the formation of life's building blocks on Bennu may exist on many other icy worlds, such as Jupiter's moon Europa and Saturn's moon Enceladus, both of which harbor subsurface oceans. As NASA prepares for future missions to explore these intriguing locations, the agency's focus on understanding the fundamental ingredients of life continues to broaden. In conclusion, the revelations from Bennu's samples not only deepen our understanding of the origins of life on Earth but also open up exciting possibilities for the existence of life elsewhere in the cosmos. As researchers continue to unravel the mysteries of these ancient materials, they may ultimately provide answers to one of humanity's most profound questions: are we alone in the universe? The ongoing exploration of asteroids and other celestial bodies carries the potential for significant discoveries that could reshape our understanding of life itself. In an exciting development for commercial space exploration, NASA has announced the upcoming launch of Axiom Mission 4X4, marking the fourth private astronaut mission to the International Space Station (ISS). Slated for launch no earlier than spring 2025. The mission will take place from NASA's Kennedy Space Center in Florida aboard a SpaceX Dragon spacecraft. This venture not only highlights the increasing role of private companies in space travel but also underscores the collaborative efforts of international space agencies. The X-4 crew is a diverse team of astronauts featuring former NASA astronaut Peggy Whitson as the mission commander, alongside Indian Space Research Organization ISRO astronaut Shubhanshu Shukla serving as the pilot. They are joined by European Space Agency ESA astronauts Laszlo Uznanski-Wisniewski from Poland and Tibor Kapu from Hungary, both of whom will be making their inaugural visits to the ISS. Whitson, who has previously commanded 2 prior Axiom missions, expressed her enthusiasm for the mission and the crew's unique contributions. "Working with the talented and diverse Ax-4 crew has been a deeply rewarding experience," she noted. "Each crew member brings unique strengths and perspectives, making our mission not just a scientific endeavor but a testament to human ingenuity and teamwork." NASA's support for private astronaut missions is part of a broader strategy to enhance access to low Earth orbit. Dana Weigel, manager of NASA's International Space Station program, emphasized the significance of these missions, stating, "As NASA looks toward the future of low Earth orbit, private astronaut missions help pave the way and expand access to the unique microgravity environment." The Ax-4 crew will spend up to 14 days aboard the islands, engaging in scientific research, outreach, and various commercial activities, further contributing to the burgeoning low Earth economy. The Ax-4 mission continues a trend that began with Axiom Mission 1 in April 2022, which marked the first private crewed mission to the ISS. Following that, Axiom Mission 2 launched in May 2023, also under Whitson's command. And Axiom Mission 3 took flight in January 2024. Each mission has progressively built upon the success of its predecessor, showcasing the capabilities of commercial spaceflight and the collaborative spirit of international space exploration. Meanwhile, in another development, NASA astronauts Suni Williams and Butch Wilmore are preparing for their upcoming spacewalk as part of their ongoing mission aboard the ISS, scheduled for January 30, 2025. This will be the station's 274th spacewalk and will involve significant tasks, including the removal of a radio frequency group assembly and the collection of surface samples for microbial research. Williams and Wilmore, who have been aboard the ISS since June 2024, initially expected their stay to last only 8 days but have embraced their extended mission, contributing to various scientific studies and operational tasks. The delays in their return, now pushed to late March 2025, were due to issues identified with Boeing's Starliner spacecraft, which necessitated changes in crew assignments and spacecraft availability. Williams remarked on the situation, stating, "Eventually we want to go home, but we have a lot to do up here and we have to get that stuff done before we go." Their positive outlook reflects the resilience and dedication that characterize the astronaut corps, as both continue to contribute to critical research and development efforts aboard the ISS. As these missions unfold, they highlight a pivotal moment in space exploration where public and private sectors converge to expand humanity's presence beyond Earth. The ongoing collaboration sets the stage for future missions, including NASA's Artemis program, which aims to return humans to the Moon and ultimately prepare for missions to Mars. With the Ax-4 mission on the horizon and the promising developments aboard the ISS, the next few years will undoubtedly witness significant advancements in our quest to explore the cosmos. In a thrilling showcase of human ingenuity and resilience, NASA's Kennedy Space Center is currently hosting a special event featuring veteran astronaut Bob Jenker. From January 28 to January 31, visitors to the Kennedy Space Center Visitor Complex have the rare opportunity to engage with Jenker, who has an impressive background in aerospace engineering and space missions. This event highlights not only the personal stories of astronauts like Jenker but also the broader significance of human space exploration in the 21st century. Jenker, a Pennsylvania native, holds multiple degrees in aerospace and electrical engineering from prestigious institutions like Penn State University and Rutgers University. His career spans extensive technical roles, including systems engineering for communications satellites at RCA and GE Aerospace Division. His first-hand experience as an astronaut offers a unique perspective on the challenges and triumphs of space travel. During the event, attendees can participate in daily astronaut encounter briefings that allow for intimate presentations and interactive question-and-answer sessions, fostering a deeper understanding of life in space. While this event captivates many, the backdrop of a monumental spacewalk taking place at the International Space Station ISS further emphasizes the exciting times for space exploration. NASA astronauts Suni Williams and Butch Wilmore are scheduled to conduct their sixth spacewalk on January 30, 2025. As part of a series of missions that delve into the uncharted realms of microbial life in space. This endeavor includes collecting samples from the ISS's exterior to analyze for microorganisms, a critical step in understanding how life might exist beyond Earth and how to prevent contamination during future missions to Mars. The upcoming spacewalk, expected to last approximately 6.5 hours, will involve the astronauts disconnecting critical communications equipment and gathering surface samples. Williams, who is on her 10th EVA, has expressed enthusiasm about the mission, stating, "We have a lot to do up here. And we have to get that stuff done before we go." The data collected from these samples will provide insights into microbial survival in space and inform NASA's planetary protection policies as humanity prepares for future explorations. The significance of the ongoing work at the ISS resonates beyond mere scientific inquiry. It serves as a testament to the collaborative efforts of various stakeholders in space exploration, including private companies like SpaceX. Recently, a delay in the return of Williams and Wilmore due to technical issues with Boeing's Starliner spacecraft has brought attention to the complexities of crewed space missions. The astronauts, who initially anticipated an 8-day mission, have extended their stay to contribute to over 60 scientific studies conducted aboard the ISS. Amidst these developments, political commentary has emerged, with former President Donald Trump urging SpaceX to expedite the return of the astronauts, highlighting the public's fascination with space travel and the nuances of its management. The astronauts, however, remain focused on their work, with Williams noting, "Living in space is super fun, despite the longing for family back on Earth." As the SpaceX Crew 10 mission approaches its launch window anticipated in late March, the excitement within the space community continues to build. The return of Williams-Wilmore and their fellow crew members will mark a significant milestone in NASA's ongoing journey of human space exploration. With events like the ones at Kennedy Space Center, the public's engagement with space science deepens, making the future of exploration not just a scientific endeavor but a shared human experience. Looking ahead, the next few months promise to be pivotal for both the astronauts aboard the ISS and the broader goals of space exploration. With groundbreaking research underway and continued collaboration across public and private sectors, the potential for new discoveries and advancements in technology remains limitless. NASA is once again at the forefront of scientific discovery as the agency prepares for a pivotal media teleconference on February 4, 2025, to discuss its groundbreaking punch polarimeter to unify the Corona and Heliosphere mission. Scheduled for launch no earlier than February 27, this mission will deploy a constellation of 4 small satellites designed to revolutionize our understanding of solar wind and its relationship with the Sun's outer atmosphere, known as the corona. The Punch mission aims to provide comprehensive 3-dimensional observations of the corona and solar wind, enhancing our knowledge of how mass and energy from the Sun interact with the Earth and the broader heliosphere. By imaging the Sun's corona and the solar wind together, we hope to understand the entire inner heliosphere as a single connected system, explained Madhulika Guthakurta, a NASA program scientist. With a dedicated team of experts including Punch mission scientist Nicolene Weil and principal investigator Craig DeForest, the teleconference promises to shed light on the mission's objectives and expected contributions to solar physics. Punch will share a launch vehicle with NASA's OSIRIS-REx space telescope aboard a SpaceX Falcon 9 rocket, marking a significant collaboration between different NASA programs. This mission is led by the Southwest Research Institute with management from NASA's Goddard Space Flight Center. The insights gleaned from Punch could illuminate the dynamics of solar activities that impact climate and technology on Earth, providing a clearer understanding of solar phenomena that have puzzled scientists for decades. In related news, a different NASA mission has yielded unexpected findings that may reshape our understanding of the origins of life. Samples returned from the asteroid Bennu by the OSIRIS-REx spacecraft have revealed a treasure trove of organic materials, including over 30 types of amino acids and the 5 nucleobases essential for RNA and DNA. This discovery, detailed in a recent study published in the journal Nature, suggests that the building blocks of life might not be unique to Earth but could also exist in other celestial bodies. The asteroid Bennu, a 500-meter-wide aggregate of boulders and dust, was targeted for its potential to harbor organic materials. Dante Loretta, a planetary scientist at the University of Arizona and leader of the OSIRIS-REx mission, remarked, "The big surprise for us was the ammonia. The enrichment of nitrogen compounds hints at a complex history that suggests Bennu may have formed in a much larger body in the outer solar system. Intriguingly, the presence of both left-handed and right-handed amino acids in the samples points to a significant question about the origins of life on Earth. This means that the left-handedness of life can't be traced back to what came in from asteroids," noted Queenie Chan, a planetary scientist at Royal Holloway, University of London, indicating that the chemical pathways that led to life may be more intricate than previously thought. The implications of these findings extend far beyond Earth, suggesting that similar organic chemistry could be occurring on other icy worlds within our solar system, such as the moons of Jupiter and Saturn. As scientists continue to analyze the pristine samples from Bennu, the potential for new discoveries about life's building blocks looms large. As NASA gears up for the Punch mission and continues to unravel the mysteries of the Bennu samples, the agency remains at the cutting edge of space exploration and astrobiology. The upcoming months are poised to witness significant advancements in our understanding of solar dynamics and the origins of life, paving the way for future explorations and discoveries that could redefine humanity's place in the cosmos. NASA's ongoing research in microgravity aboard the International Space Station (ISS) is revealing groundbreaking insights that could transform both space exploration and everyday technology on Earth. Conducting 6 key experiments, NASA scientists are delving into the behavior of materials ranging from metals to foams, aiming to harness the unique conditions of space to develop innovative solutions for challenges faced both beyond our planet and here at home. One of the pivotal studies, known as the brazing of aluminum alloys in SpaceBrain's experiment, investigates how liquid metals behave in microgravity during the brazing process, essentially the joining of materials at high temperatures. This research could revolutionize construction techniques for spacecraft and habitats, allowing for robust repairs in the harsh environment of space. As the team notes, advanced brazing technologies discovered in space may also find applications in repairing infrastructure on Earth. Another significant area of study focuses on semiconductor crystals, particularly zinc selenide (ZNSE), which are critical for optical devices and infrared lasers. By examining how microgravity affects the growth of these crystals, researchers anticipate improvements that could enhance the performance of commercial products, potentially leading to greater efficiency and lower costs in industries reliant on advanced optics. Further, NASA is pushing the boundaries of metal alloy development. Researchers are analyzing how metal alloys solidify in a microgravity environment, where the formation of dendrites, snowflake-like structures that influence metal strength, can be controlled more precisely. The implications of this research extend far beyond the ISS, promising stronger, more resilient materials for use in a variety of applications, from aerospace to automotive manufacturing. In addition to metals, NASA is exploring the behavior of foams and bubbly liquids. This research is not merely academic, it has practical applications for developing life support systems for missions to Mars and beyond. A better understanding of how these materials behave could lead to more efficient water recovery and recycling systems, an essential component for long-duration missions. Another intriguing experiment involves supercooled metal oxides, which may pave the way for manufacturing new products using Martian resources. This could be a game-changer for future habitats, utilizing local materials to create essential tools and structures, thereby reducing the need to send resources from Earth. Lastly, the exploration of soft matter through colloid behavior in microgravity could lead to advancements in 3D printing technologies and the development of new materials with applications across multiple sectors, including energy and communications. NASA's commitment to harnessing the unique conditions of space is not only about improving technologies for space exploration, it has far-reaching implications for Earth. The agency's research endeavors in microgravity serve as a catalyst for innovation, fostering advancements that could enhance our daily lives and contribute to sustainable practices. As we look toward the future, the results from these experiments may soon culminate in practical applications that benefit both space missions and terrestrial industries. With plans for a human presence on Mars in the 2030s, the significance of these experiments grows ever more critical, positioning NASA at the forefront of technological advancement in the quest for further exploration of our solar system. The intersection of space research and everyday technology heralds a new era of possibilities, promising to reshape our relationship with materials and resources both on Earth and beyond. In the vast expanse of our solar system, the quest for knowledge about celestial bodies continues to reveal astonishing phenomena. Recently, NASA's Juno mission has made headlines with its groundbreaking discovery of a colossal volcanic hotspot on Jupiter's moon Io, raising questions and excitement about the dynamics of volcanism beyond Earth. This revelation not only underscores Io's status as the most volcanically active body in the solar system, but also emphasizes the potential for understanding volcanic processes in different environments. On December 27, 2024, during a routine flyby, the Juno spacecraft utilized its Jovian infrared auroral mapper GIROM instrument to detect an unprecedented volcanic event on Io, which has been described as the most powerful eruption ever recorded on this tumultuous moon. The hotspot observed spans an astonishing 40,000 square miles, dwarfing the previously recognized record holder Loki Patera, which covers just 7,700 square miles. This is the most powerful volcanic event ever recorded on the most volcanic world in our solar system, so that's really saying something, remarked Scott Bolton, principal investigator of the Juno mission. The intense volcanic activity on Io is a result of its unique orbital dynamics. Orbiting close to Jupiter, the moon experiences significant gravitational forces that create a tug-of-war with its neighboring Galilean moons Europa and Ganymede. This gravitational interaction generates frictional heating within Io, leading to the melting of its interior and the eruption of lava plumes. Scientists estimate that Io hosts around 400 volcanoes, making it a focal point for studying extraterrestrial volcanism. The detection of this massive hotspot was made possible through GIROM's capability to observe in infrared light, enabling the identification of features that are invisible to the naked eye. Juno's mission, which has been extended to include detailed studies of Jupiter's moons, will continue to monitor this newly discovered volcanic feature. An upcoming flyby scheduled for March 3, 2025 aims to assess changes in the landscape, providing further insights into the dynamics of Io's volcanic activity. Meanwhile, another exciting development in lunar exploration has emerged from research conducted by scientists at the University of California, San Diego. This team, led by Mark Thymans, has made significant strides in understanding the origins of water on the moon, a critical resource for future lunar habitation and exploration. Their findings suggest that much of the moon's water likely stems from two primary sources: indigenous water from the moon itself and water deposited by icy comets. The researchers employed advanced techniques to analyze lunar rocks collected during the Apollo 11 mission, uncovering insights into the water's origins through isotopic analysis. The study, published in the Proceedings of the National Academy of Sciences, posits that while water exists on the moon, its distribution and origin are complex and merit further investigation. This kind of work hasn't been done before, and we think it can provide NASA with some valuable clues about where water is located on the moon, Thymans stated. As humanity sets its sights on establishing a sustainable presence on the moon and Mars, understanding the availability and origins of water will be paramount. The findings from UC San Diego not only shed light on the moon's past but also have implications for future missions under NASA's Artemis program, which aims to return humans to the lunar surface and eventually pave the way for Mars exploration. Together, these discoveries from Juno and the UC San Diego team highlight the ongoing evolution of our understanding of celestial bodies within our solar system. They remind us that each new finding brings us closer to unraveling the mysteries of our universe, paving the way for further exploration and potential colonization. As missions continue to evolve and expand, the scientific community eagerly anticipates what additional revelations will emerge in the coming years.